Okay, sorry, it's going to be atomic structure part 3. Even though this is not part of the California standards, you have to know it for me. Quantum numbers. Quantum numbers are 4 numbers used to describe the energy and most probable location of an electron. There are 4 quantum numbers. N equals principal energy level. The principal energy level tells you several things. It tells you, number 1, the amount of energy. Number 2, it tells you distance from the nucleus. Number 3, it tells you the size of the electron cloud. N can be equal to 1, 2, 3, 4, 5, a billion. Okay? Now, let's show it. N equals 1. N equals 2. N equals 3. The lower the energy level, the lower the amount of energy. The closer to the nucleus, the smaller the electron cloud. So if you're going to compare N equals 1 versus N equals 2, N equals 1 has lower energy than N equals 2. N equals 1 is closer to the nucleus than N equals 2. N equals 1 is a smaller electron cloud than N equals 2. As distance from the nucleus increases, amount of energy increases. Also, the formula 2n squared tells you how many electrons can be in that energy level. So if n equals 1, 1 squared is 1 times 2, there can be 2 electrons. If n equals 2, 2 squared is 4 times 2 is 8, there can be 8 electrons in the second energy level. If n equals 3, 3 squared is 9 times 2 is 18 electrons. And if n equals 4, 4 squared is 16 times 2, 32 electrons. 2, 8, 18, 32. Principal energy level, the first quantum number. The second quantum number is L. L is sublevels. The sublevel of an atom tells you the general shape. Remember? Okay? Every energy level is made up of sublevels. In the first energy level, there's one sublevel. What's its name? 1s. Remember, an S has a spherical shape. When n equals 2, there are 2 levels. 2s, 2p. S is sphere, P is dumbbell. When n equals 3, you have 3 sublevels. 3s, 3p, 3d. 3s, sphere, 3p, dumbbell, 3d, beyond the scope of this course. N equals 4, 4 sublevels. 4s, 4p, 4d, 4f. Okay? S, P, D, F. Okay? Here are our sublevels. Now, our third quantum number is going to be something called orbitals. Orbitals has to do with orientation. How is the electron cloud directed in space? Okay? Now, in the first energy level, n equals 1, there's one sublevel, 1s, there's only one orbital. Now, how many electrons go in each orbital? 2. So you can actually have a 1s2. Remember this? Okay? Now let's go to n equals 2. You have 2s. Again, there's only one orbital in a 2s sublevel, one orbital. So you can have 2s2 because how many electrons go in an orbital? 2. Now, we have something called 2p. Remember? S, P, D, F. Okay? P has 3 orbitals. How many electrons go in each orbital? 2. So how many electrons can be in a 2p sublevel? 6. Remember this? 1s2, 2s2, 2p6, 3s2, 3p6, 3d10. Okay? So, S, P, D, F. 1 orbital, P, 3, D, 5, F, 7. Remember how they fill? Okay, let's look at the last one. S for spin. Remember, they can spin in opposite directions. So in each orbital, we say that one electron spins clockwise, the other electron spins counterclockwise. So let's do it. Okay? S. Up, down. Let's do P. They don't pair until they have to. Remember this? D. They don't pair until they have to. Empty seat on the bus principle, right? F. They don't pair until they have to. Okay. Now the Pauli exclusion principle says that no 2 electrons can have the same 4 quantum numbers in an atom. 3 can be the same, 2 can be the same, 1 can be the same, but not all 4. Okay? Now the Aufbau principle says that electrons will go into lower energy levels first. Okay? So, remember, here it goes. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Don't forget the diagonal rule. I would put that in somewhere. This tells you the order in which electrons fill. Thank you.